So this side right here is the ball mill operation. So it controls and runs the ball mill, cyclones, and all the pumps that are associated with that side of the mill. This side here is our flotation side, and it runs our some of our chemical additions. It also keeps track of our online analyzer, stream analyzer. And so this screen here tells us, so you have it in your feed, and it'll tell you the concentration of silver and copper in each of those different streams. Take a sample, and it uses X-rays to determine what the concentrations of those are. It's not highly accurate, but it is reasonably enough to control the process. It lets the operators keep track of what's going on inside the mill and during the flotation part. So I cleaned up some of our feed material so you guys can look at it. So that's the material that we feed into our ball mills. And that's after it's been crushed up in both the primary and the secondary. So you'll probably see part of the primary when you guys go underground. The secondary is going to be above us. We're not going to go into the secondary. But it reduces the rock to somewhere around a ½ inch. Some oversized. It travels down to the secondary where it gets further crushed. It repeats the crushing cycle. It goes through screens. When it's finer than a ½ inch or finer, then it's a good example of what the heads are because it looks very similar. We grind it to about 106 microns, the material. So it's fairly fine. It's finer than beach sand. You can still feel it has a grittiness to it. This is our concentrate. So this is copper and silver. And it's about 40% copper and somewhere around 100 ounces per ton silver. Inside there.
How much ore would it take to get that much down?
So our feed grade is between 0.3 and 0.5% copper and around 1 ounce per ton. So that's why we have these processes to enrich that material to make our final con. And that concentrate is in ground very fine, about like flour. So it's finer than 45 microns. And that's to make sure we liberate all the waste from it and then just collecting the ore itself. But we use chemicals to actually float it to the surface. And it's basically like soap. It's very difficult to recover, and I'll go through how we actually attempt to recover the non-sulfides in our rock.
This is where they float the ore off the top.
I want to touch it. Is it hot?
No.
Large material is returned back to the mill. Fine material that goes to that stuff.
There's the dryer, I think.
Yeah.
Then it's been fine at 106 microns.
So that's this stuff that's dried onto that, and then as it comes around, it's scraped off.
There's a little splitter pull out the samples with the monitoring process. It runs through the OSA to go up to the pressure of the gas flash. I'll put it in gas flash.
No, this turns into that.
All three of these rows are identical. This is our sulfide circuit. It's close to the mill. It already has the xanthate added to it, which makes it hydrophobic. We have the MIBC, which is wrong. That's the MIBC, it's wrong. All this material is hydrophobic because of the air bubbles, the clouds, which is wrong. It's been brought surface is floated off. All the material that doesn't have the ore in it stays in the solution and it's pumped down, it flows on down. So it sort of comes off. This is the most concentrated material. It's probably as high as 30% copper. It starts to decrease down. It's right from these troughs. It goes to these subs down below. And we're not going to go down to the subs, but
Oh, so each one of these is a different stage?
This is one stage. The light tan is the second stage. There isn't nearly as much in it.
Something like that, yeah.
That is, no, it's just gritty, but it's about 30% copper.
That's copper? Keep it on your fingers
Well,
and take it in.
it's 30%
I
copper.
want to make a penny.
I think it's the second stage. I could be wrong though. It's not as dark, so it's probably not as concentrated.
same thing in there. Settling out, taking out the bottom. The material comes over here, regrind mill. We'll go take a look at it. the stuff that comes up from the regrind mill, just like on the other side, runs through the cyclone. Big cyclones right up there. It separates it out. So this right here is our drum filter. And so all the material, the constant thickener, comes over here. There's actually a tub underneath. That's about 50% solids. So it's fairly thick. It's about like maybe a real thin milkshake or something like that. It's pretty thick. We use a vacuum pump to blow us. And first it sucks the material onto this filter. It's actually like a cloth filter. It sucks the material onto it. Gets to the next stage, and it sucks harder and removes the water at that point. So we reduce it to about 13% water. So it's still sort of right on 45. And initially,
So it just, is it falling into a truck or is it just falling into a container? If you listen, you can hear the vacuum connected to it when they suck the water out of the foam.
As you run the whole process.
Just don't lose a finger. So yeah, see how it's in a vat of that froth? This is a big vacuum. It pulls air out of the drum, so it sucks that stuff to the drum itself, and then as it turns in a slow circle, it pulls the water out of the material.
Did you mention that it's cloth and not
So it's like a sponge.
net?
It's a cloth, not
That's
netting.
cloth, yeah.